I'm Ian Clark, and this is my Interactive Advanced Concept Presentation 1 for Chemistry 2. This is the gummy bear experiment, and in this experiment I have been soaking a couple gummy bears, this one in tap water and this one in a saltwater solution now for right at 10 hours. And then I have a regular gummy bear out here for comparison. I'll flip the camera around in a second. So we're gonna look at all these. Essentially, this assignment or this presentation will cover osmosis, and where molecules pass through a semi-permeable membrane from a less concentrated solution to a more concentrated solution. So your isotonic is when solute concentrations are the same on each side of the membrane. So if that was the case with the gummy bear, it would be the same within the gummy bear or the same outside the gummy bear, similar to cells. It's the same. If it's isotonic, it's the same inside the cell as the same as outside the cell. Then you have hypertonic and hypotonic. And hypotonic is if the solute concentration is higher on the inside of the cell. The salt or if this hypertonic will pull the water outside because the concentration is higher on the inside of the cell. So like the salt water in this solution is hypertonic because it has a higher concentration of the solute outside of the cell. And then hypotonic, the solute concentration is lower than the solution, so water will diffuse inside of the cell. So with the gummy bear, we should see this with the tap water as water penetrates the semi-permeable membrane into the cell, and it should swell. So like I said, the tap water is hypotonic to the gummy bear, and the salt water should be hypertonic. So gummy bears, they consist of gelatin, sugar, and starch whenever they're made. And gelatin is the polymer, so it essentially covers the outside of the gummy bear, and it makes a membrane on it. And whenever they're made, the water it evaporates, or it's pulled from the gummy bear in the heating process, and you're left with this squishy, semi-hard substance. So let's pull these gummy bears out and take a look, and I'll flip them around. So the first one I'm going to pull out is the tap water one. And as we can see, outside here, I'll lay it down, it's got quite a bit more hard, or quite a bit more squishy and much larger. And I'll pull out the saltwater one. Set this over here. So looking at these, turn the camera around, we can see 3 gummy bears there, and the tap water one is much larger. The regular gummy bear is, as you can see, the original size, and then the saltwater one ended up being hypertonic saltwater gummy bear ended up actually being larger than the regular one, but smaller than the tap water gummy bear. So, and it has like a kind of an odd coating on it from the salt. But as you can see, the water came into the gummy bear from the outside. On the tap water is that there was no water within the gummy bears, and it's hypotonic, so it pulled the solution, the water, into the inside. It looks like the same thing happened with the salt water. So I mixed the salt into the water as well as I could, but the more I put, I started piling up on the bottom. So I figured that it was as saturated, or maybe it's now super saturated, as much as possible. So the saltwater gummy bear didn't grow as much as the tap water, and I suspect that maybe the salt didn't mix up as well, so it still pulled some of the water molecules through the semi-permeable membrane of the saltwater gummy bear, but not near as much as the tap water. So that concludes my Interactive Advanced Concept Presentation 1.